Dear all, welcome to the material science class, and here now today's topic was a polymer composite material. So here in the polymer composite material, so today we are going to learn what, where, why, and how. So these are the four factors we are going to learn in today's class. Next we will see research methodologies and research scope, and we see the composite and alloy. So here, when come to the definition of the composite is a combination of two or more different materials. At the same time, the alloy is also a combination of two or more different materials. And what is the basic difference between this composite and an alloy? So here comes to the question. So here, in the composite, even after combination of two or more materials, every material will have its own physical identity. It won't lose its physical identity. But in the alloy, so after combination, it will going to lose its physical identity. So here you can see the beam. So here we have iron bars and as well as concrete. Even after 20 years or 30 years, if you break the wall, you can see, you can separate that as this is an iron rod and this is a concrete. But suppose here we do have an alloy, that is here it is a steel one. It's a combination of iron, carbon, magnesium, and zinc, so on, so other elements. So here in this one, so now we can't able to with an naked eye and physically we can't separate this as this is a steel, sorry, this is an iron and this is a carbon, this is a chromium, so this is a nickel. These are the elements we do have in this. So that is even after combination, the every metal loses its physical identity in the alloy, but in the composite we do have a physical identity even after combination. Here we have what are the constraints in the composite material. In the composite materials we have majorly two elements. The first one is a fiber and the second one is a matrix. The fiber is the discontinuous one, and a fiber is a discontinuous one, and as well as a stronger and a harder one, and matrix is a continuous one. So suppose we take your hand as an example. Here the bone is a bone is a reinforcement, and supporting matrix of a flesh is a supporting matrix. So your hand is a composite material. So your entire human body you can consider, but as of now I am saying the hand. Yeah. So fibers. So what are the fibers? We have a natural fibers and also we have a artificial fibers. The natural fibers, what are the natural fibers we have? It's a loofah, palm, jute, rice husk, canaf, banana, chicken feather, cotton, coir, abaca, flax, sisal, and a lot of many more things that is which we can extract from the nature. We can consider as a natural fibers. And so the fibers which we manufacture in the industries, that we consider as a synthetic fiber. Here we have a carbon fiber, basalt fiber, glass fiber, and Kevlar fibers. So the classification based on the arrangement of fibers, that is we have so classification of the composite materials. The composite materials are classified based upon the arrangement of the fibers. Here we have a so based upon the arrangement of the fibers, we have suppose if you take the fibers in the form of a powder, then we call it a particle reinforced composite. The fibers in the form of a cloth, then we call it a bidirectional composite material. Suppose in the form of a strips, then we call it a unidirectional composite material. Suppose if you take it in small pieces, and if small pieces are kept in a proper direction, then it is aligned composite material. And suppose if they are randomly oriented, then it is called a randomly oriented composite material. And if it is a combination of any two of the existing types, we normally call it a hybrid polymer composite material. So we know that in early 2000 there is a revolution that in the Boeing 787 flight, the most of the 80 to 90% of the components are manufactured with help of a composite material. So you can see the entire blue color one is a carbon composite laminate, except the red color one is aluminum, and the yellow color one was the again the aluminum titanium polygon. In this view you can't see the most of the yellow color things, and very rare red color things you can say. The remaining everything is a composite panels. So the application of the composite was not started today. So it was started in the early 4000 BC. Normally they are making some writing materials from papyrus plants, and also in the 1300 BC, so they are using straw bricks. And 1200 AD, the Mongolians invented the composite bow. So the composite bow was one of the revolutionary thing in those days. So by the modern world also we do have during the Second World War for military applications, and non-metallic radar equipments. So a lot of applications are there for the composites even during the Second World War itself. In today's life, what not, wherever you can go, you can see the composite material. These are the few areas that is, even if you go for the music, we have a guitars made of composite material, and other drums and all things also we do made of composite materials. In the textile industry, paper industry, and also we have composites in the aerospace, composites in the automotive, composites in the civil engineering, composites in the sporting goods. Most of the rackets, shuttle rackets, hockey sticks, everything nowadays we have a composite. And in the energy production as well as in the power sources, however we have composite material. Even in the body implants also we are having composite materials nowadays. And in the marine industry also the composite materials are used. So here we have a few day-to-day applications we have the composite materials. So these are the specific applications of the composite materials where we can use apply the specific composite materials. And why we need these composite materials? So for weight reduction we need the first one, and also for easy to assemble the complex parts during the automated layout machinery. And the third one was the mechanical properties tailored depending upon the requirements. You can modify the mechanical properties of the material by varying the fiber percentage, or by varying the orientation of the fiber, or changing the matrix thing, or by adding some other particles to it. So we can tailor the mechanical properties as per our requirement. And we do have thermal stability. So it won't much expand or contract extensively with the change in temperatures, as metals are more have thermal stresses, but the composites will have very less thermal stresses. And it will have a high impact resistance, like Kevlar and other fibers will have a high impact resistance. And also we can reduce the galvanic corrosion problems, especially in marine industries. Whenever a ship is made with a different material, when two different materials are in touch with the water continuously, so due to this galvanic current, the galvanic corrosion will occur. So here, in order to avoid such galvanic corrosion problems, we go with the polymer composites, since they are non-conductive materials. And also we have fatigue and corrosion problems are virtually eliminated. How the composites are made? Mostly the easiest one was the open mold process, and we do have a closed mold process, and we do have a wide drying process. So we do have a filtration and extrusion of various processes we do have. So this is about basics of composite material. In the next class, we will see in detail about how to manufacture a composite material and what are the processes we do have. Thank you.